If everyone's ready, we'll go. We'll start. Good morning, everyone. Thank you for attending. I'd like to welcome you all to our fifth episode of season 2 of the Loops webinar. Loops is a live webinar series that focuses on highlighting the innovation produced by Horizon 2020 funded projects in the field of social innovation and circular economy. I'm Robert Brockin. I'm the Communications Assistant at Felte. The topic that we will be discussing today is raw materials, and to help that discussion today, we have invited 2 Horizon 2020 projects from the ION4RAW project. We've invited the project coordinator, Maria Tripiana, and from Tarantula, we have invited Dr. Nader Akil. So again, thank you for attending, and to start off the webinar, I'd just like the guests to introduce themselves, if they can.
I can start if you want. So
Yeah,
my name is Maria Tripiana, and I work as a team leader and project manager in IDENER. IDENER is a company which is located in Sevilla, in Spain, and what we do mainly is the development of computational science tools for system optimization, and we're also quite active in the Horizon 2020 and Horizon Europe projects and framework. So thank you very much, Robert, for having me in this webinar.
Nader?
Thank you, Robert. My name is Nader Akil. I'm the EU team manager at P&O Innovation. We are located here in Brussels. P&O has about 400 consultants across Europe in 7 European countries with about 30 offices. And our core business is to develop innovative projects and proposal. And normally those proposals get funded by different, let's say, funding authorities like the Commission or the member states as well, or the government. Thank you, Robert.
Thank you. Yeah, so just the webinar will be, we'll have 2 presentations from both the projects showcasing their work. And then at the end, we'll have a short Q&A. So if you want to ask a question, go ahead in the YouTube chat. We've had issues with the LinkedIn event page. Usually we take questions there, but today we can't. So if you have a question, please ask on the YouTube live chat. And that's it really. If Maria, would you like to start your presentation?
Okay, great. Perfect. So today I'm going to talk a little bit about our project, ION4RAW, which long title is Ionometallurgica of Primary Sources for an Enhanced Raw Materials Recovery. And first of all, I would like to start with what is ION4RAW. So the idea with this project is to develop a new energy and material efficient mineral processing technology to recover byproducts from primary sources by means of detective solvents, ionic liquids, and advanced electrorecovery as only one step. So these are the most targeted byproducts that we want to recover with our ION4RAW project. As you can see from the image, many of them are critical raw materials such as bismuth, germanium, indium, cobalt, platinum, and antimony. And we are also recovering the accompanying major product metals such as copper, silver, and gold. This is our consortium. We are 13 partners from 8 different countries, 7 from the European Union, plus a partner from Peru. Our budget for this action is 5.6 million euros, and we started in June 2019, and the project will be running until November 2023. As we said before, this is an Horizon 2020 project, and it is a research and innovation action. So in the coming slides, I would like to give you an idea of the value chain of the ION4RAW project, starting from our partners who are providing the ore and the materials that we are going to test in the project. So we have here Scott Gold Resources and Cumbrex, which are direct partners from the project and are providing some of the minerals. And we have also Cobre Las Cruces and Oro Valle, both in Spain, and they are part of our external expert advisory board, and they are also providing these materials to be tested within the project. So with these materials, we started with a byproduct evaluation by BRGN with the idea to characterize all these materials and to know what we are working with. And then we will start with the main project. We have the upstream activities, which are going to be developing water landstream installations. We have downstream activities, which are studied by Loredeta. And then we have the ionometallurgical process, as I said before, with these DES, deep protected solvents, ionic liquids, and also with the electro recovery part. We have several partners working quite actively right now here, which are Tecnalia, Sintef, HCDR, and Freiburg University. And the idea with once that we have some feedback and information with all this technical part, we are also developing process design and optimization. Ediner is taking care of that. And at the end, we will do a validation in Tecnalia's facilities. We have also the partners involved, for example, RINA, Ediner also, and the University of Freiburg in this part of the validation. And of course, we have covering all this complete value chain. We have the activities related to communication and dissemination and the sustainability assessment and exploitation covered by LGA, RINA, and PNO. So this is our complete value chain for the project. Here, the idea is to develop a flexible process that could increase its market penetration potential as a sound systemic solution. Also, this concept of the ION4RAW was supported at the beginning for a TRL 2-3, and we aim to reach a TRL 5 by implementing this process, a prototype of the process at Tecnalia's facilities. This is our Gantt chart. All the activities that I mentioned before are covered here for different work packages. We are at the moment here in this part of the Gantt, we have the activities, the work packages related to the sustainability assessment, dissemination and communication, and project management that are working during the whole life of the project. Then we have the byproducts potential evaluation, which is also ongoing at the moment. The most technical work packages for the upstream and downstream activities, the process itself, and also the integration, design, and optimization, which are almost finishing with the idea to start working on the upscaling and the demo validation next year. So for the goals and outputs of our project, we have as a first goal to encourage and support byproduct recovery by conducting a byproduct potential identification and assessment. This objective, we can say that it is already achieved in the project. We have also the promotion of the dissemination and communication of the project's results, also expanding the impact, and also, of course, the sustainability from an economic, technical, and environmental point of view. These are objectives that will be going little by little during the whole life of the project. Also more technical objectives, for example, maximizing the upstream recovery of the byproducts from these primary sources that we are working with. Also minimizing the downstream environmental impact. We are working also on the cost-efficient recovery by products from the primary sources with the ionometallurgical route that I mentioned before, and the design and optimization of the overall process using a multidisciplinary optimization approach. These activities are ongoing with the idea to start, as I said before, next year with the validation of the ION4RAW process. And here I also summarize some of the impacts of our project. There are several different impacts for the ION4RAW, but I cover all of them in two. The first one is to push the European Union to the forefront in raw materials processing technologies and solutions. And here we can talk about that the ION4RAW will be able to use a technology that is more environmentally friendly because of the use of this. Also more resource and cost efficient than the conventional ionometallurgical processes. We are using as a process that has a low energy consumption. It's not a very energy intensive one. And what we are doing also is to lower the number of processing steps for the complete solution. Also, we want to make a flexible process to treat different types of minerals and recover different metals. And the idea, this is something that is not covered by the ION4RAW project, but it has also potential to recover byproducts from secondary sources, not only primary sources. And of course, the improvement of the awareness, acceptance, and trust of society in a sustainable raw materials production. We are in this part, we are working on a set of communication activities and materials to reach very different targeted audiences. And the second impact that I have here is to unlock substantial reserves of new or currently unexploited resources within the European Union. This is something that is quite advanced at the moment with the ION4RAW project. We created a geographically based compilation of the ION4RAW targeted by products, and also developed a value chain based compilation of these targeted by products, including the economic importance, supply risk, and updating also the criticality of each element. And the good thing is all this information is public, and it's already available from our webpage and also from Cordis. I think that people can also access it from the Cordis webpage. And this is more or less what I have for the presentation of the ION4 project, for ION4 project, Robert. So thank you.
Thanks, Maria. That was great. Nader, will I add yours to the screen now? Yeah, or would you like to share your screen?
I will share my screen.
Okay.
Can you see my screen?
Yeah, it's kind of. I don't think it's working. There seems to be an issue with the. It's like flickering.
Okay, then I will.
Oh, there we go. I think it.
Okay, I will try again to share my screen.
Yeah, there it is. There. If you'd like to put it in presentation mode.
Yes.
Yeah.
Okay, is it? Yeah, now is it the presentation mode, right?
Yeah.
Okay. Well, thank you, Robert, for giving me the opportunity to present the Tarantula project, which deals with the recovery of tungsten, niobium, and tantalum occurring as byproducts in mining and processing waste streams. This presentation has been prepared by the coordinator Technalia with input from several partners of the projects, mainly Vito, KU11, Chalmers, and P&O. P&O is a partner in the project, supporting the dissemination, communication, and exploitation activity of the project. This is the outline of my presentation. So basically, first I will discuss why we are focusing on those refractory metals and their importance for the EU economy. Then I will present the Tarantula projects, its aim, technologies, and activities. And then I will show some of the results that we have got so far in the project. So tungsten, tantalum, and niobium are refractory metals, as you know, and they are listed as a critical raw material by the European Commission because of their high economic importance, but also high risk of supply. The EU depends very much on the import, and in some cases, it's almost 100% for niobium and tantalum. To a less extent to tungsten, because we have some production in Europe. However, tungsten has the highest economic importance of all critical raw materials that they are listed on the EC since 2000, on the EC list since 2010. It's mainly used in the cemented carbide as really like hard materials used into application like cutting or component wear used in mining, machining, constructions, and other application where high strong or strong, let's say, material is needed. For instance, here you have some examples of the tungsten carbide drills that we are all using, but also in tungsten carbide inserts that they are used for the manufacturing of machines. So basically, it's used mainly in the cemented carbide, but also in other applications such as chemicals and super alloys, and also other applications in Europe. Basically, China accounts for more than 80% of the world's tungsten production. But we have some primary production from in Europe, mainly coming from mines located in Portugal, Spain, and Austria. But it's not enough to cover the domestic demand. Tantalum has highly resistance to wear, corrosion, and heat, and is mainly used in Europe in several applications, such as capacitors, for instance, that are used into telecommunication or microelectronics, but also in let's say in other applications, for instance, as a super alloys and carbides, that they are used also in cutting steels or super alloys in equipment, nuclear reactors, missile parts. So all those applications are very important for Europe, and the EU depends 100% on the import of tantalum, mainly from Africa. The other material is niobium, which is an essential component of high-strength, low-alloy steels. Is used in several applications in Europe, mainly in automotive, but structures, pipelines, and also super alloys, where it's used mainly in the aerospace industries, like aircraft engines, or land-based gas turbines for electricity generation. We have let's say, also for niobium, the EU depends almost 100% on the import, and mainly from Brazil and Canada. So the challenge that we are trying to solve with the Tarantula project is basically to exploit the potential of tungsten, niobium, and tantalum entrapped in complex low-grade resources within the EU territory. This project has started in June, 1st of June 2019, and it's running for 4 years. So we are about midway, and is coordinated by Tecnalia in Spain, and received about 6.9 million euros grant from the Commission. There are 16 European partners in this project, covering the whole value chain, research centers, but university and companies and industry associations, where mainly the materials that will be supplied by several companies such as Saloros, a mining company in Spain, but also Strategic Minerals, also in Spain, and the Cronimet, which is one of the major manufacturer of carbide materials. The goal that we are trying to achieve with the Tarantula is to reduce the EU dependence on refractory metals imports by valorizing unconventional European resources. We are going to do that by developing novel metallurgical technologies to increase the recovery rates and selectivity, to finally unlock the metals from resources that are currently considered as waste. So basically, there are several materials that are being considered in Tarantula. Material from primary resources, such as tailings and concentrates from tungsten, tantalum, and niobium mineral ores. So basically, for some of them, let's say mainly for tantalum and niobium, we might have a radioactive concentrates that need to be treated, let's say, with care in the project. I will come back to this point later on. We are also considering, let's say, the slags that are coming from, let's say, mining and smelting residues of tin, which could contain also radioactive materials. And then we are also considering a sort of secondary raw materials, which are the process residues from the carbide manufacturing cycle. So this is the work plan of the projects. Basically, we have 6 technical work packages, if we might call them like that. So with work package 2, we have an important activity by eMines about the identification of European resources of refractory metals. We have also very good, let's say, data for the deposits across Europe. And then we have a few technical work package, mainly work package 3 for the supply, characterization, and pre-processing of the waste, of the raw material, of the feedstock that we will be receiving. Extraction and recovery of the refractory metals as oxide or salts in work package 4. In work package 5, we will be producing the metal carbide and metal oxides. And in work package 6, we will guide the selection of the best performing, let's say, technologies based on sustainability assessment and selection of optimal flow sheet that will be basically validated and upscaled and validated in work package 7. And the material also that will be delivered will be validated in the final applications. Additionally, we will have work package 1 for the management and work package 8 for communication, dissemination, exploitation, and clustering. So those are the technologies and the flow sheet that are considered in Tarantula. As I mentioned, let's say some of the feedstock might contain radioactive material. Therefore, all the material that are received are first sent to Chalmers, where they are characterized for their radioactivity. And then if they are safe under a certain threshold, then they are dispatched to the partners for further processing. If not, then they are kept at Chalmers and they are processed with the specific process for the removal of potential harmful materials. Of course, we have the pre-treatment, let's say, first, and specifically for the tailings that might contain very low-grade material, followed up by several processing steps for the extraction, separation, and metal or metal oxide production. For now, I will focus only on the results so far that we have in the extraction and separation process here, which are led by a few partners, KU Leuven, Technalia, Vito, and Chalmers. So basically, with the KU Leuven process, we are using solvo-leaching and non-aqueous solvent extraction. This is a process which is known to reduce quite a lot the consumption of water in the process. And then when it's followed by precipitation and calcination, then we can obtain the metal oxides. The process of Technalia focus on the use of deep autotic solvent and leaching and ionic liquid extraction processes. And the importance of this, let's say, process is that it's eco-friendly because the deep autodic solvent is kind of a biodegradable material, and it can work at mild temperature between 40 and 70 degrees. And also when followed by precipitation and calcination, we can obtain the metal oxides. The process of Vito is based on alkaline fusion and water leaching, followed by a process of, let's say, sorption. The importance of this process is that it's integrated in one processing steps to basically to produce the metal oxides. And then with the Chalmers, as said before, so we are using a specific process, alkaline leaching and solvent extraction, in order to remove any hazardous material from radioactive, let's say, tantalum and niobium containing materials. This is the achievement so far with the several processes here for the tungsten, for medium grade concentrates, where we have succeeded to achieve high tungsten recovery yields, more than 90%, as shown in some of those graphs. For instance, here with Vito technology, we can see that the tungsten, let's say, recovery yield was more than 90%, and the leaching time was, let's say, as between 30 and 120 minutes for performing this operation. The other, let's say, partners, they have also worked in indoor technologies. For instance, this one for the ionic liquid, so deep autodic solvent and ionic liquid extraction by Technalia, showing also, let's say, leaching time of 5 hours and the yield more than 90% with a temperature around 60 degree. For the pre-treated tailings, we have achieved also high tungsten recovery yield between 70 and 80%. As for the tantalum and niobium, so far we had some results on pure mineral, the coltan, the Colombo tantalite, let's say, material, where we have achieved high tantalum and niobium extraction yields, more than 80%, as can be seen here, for instance, with the process of Technalia, where it shows here that we have a high yield, and here with some parameters, for instance, when we use ball milling or we don't use ball milling, it shows like a huge difference in the leaching, let's say, leachability, basically, because the ball milling, it just like make it easier for the leaching to be processed. For the concentrates, they are currently under optimizations. So here we have it from Chalmers, for instance, but they are still under optimization in order to achieve higher yield. So basically, those are the main achievement that we wanted to share with you today. And I will end up with these slides, which shows the project website so that you can consult, and also the, let's say, contact details of the project coordinator, Dr. Amal Siriwardana from Technalia, that you also can contact in case of you have any inquiry about the project. Thank you very much.
Yeah, thank you. It's very exciting to see, the work that is being done in the area of raw materials across Europe. Yeah, thanks a lot. We'll start our Q&A then. If anyone would like to ask a question, go ahead in the YouTube chat, and I'm sure they'd love to answer. Um, yeah, so I'll start the Q&A off. Just both projects are like they're quite that you've known each other beforehand. We discovered this, but as you are watching each other, have you discovered any curiosity? Have any questions about each of their projects?
Do you mean, Robert, regarding the technology, the research which are under development for each technology?
Yeah, no, it's just if as you are watching the both presentations, if you have any questions or curiosity about each other, like what the
Okay.
project. Yeah,
I
sorry.
have one curiosity, one question for Nader, because as you were mentioning that there are several routes for the tarantula process, and one of them will be selected at the end. So the idea is that this route is flexible enough to treat the the products from niobium and tantalum and also tungsten, or there will be like two different routes, one for tungsten and another one for tantalum and niobium.
Well, the selection of the process, of course, the flexibility, it will be one parameter in the, let's say, sustainability assessment. But we have also to be realistic. So, let's say, tantalum and niobium, as I said, like sometimes they have kind of radioactive material that they cannot really, they need to be treated in a different process. At the end, of course, we are aiming to have a process that is as flexible as possible for certain type of feedstock. Let's say what we can really have. But we have also to be realistic on the type of feedstock that can be processed at the end. But I see your question, and I can say like the flexibility, it's always a parameter in the selection procedure in the, let's say, sustainability assessment, together with other parameters like the cost, like the environmental impacts, and so on. And at a certain moment, that there will be a selection done based on which, let's say, processes are, let's say, ticking most of the boxes. But if the process does not work, or it needs some really very specific treatment, then the flow chart, it will be also adapted to take into account the possibility also to treat, let's say, radioactive material.
Okay, perfect. Yes, I understand that it will be like a multi-criteria analysis, taking into account all the different parameters, all the aspects for the economics and environmental part, and so on. So, okay, great.
Absolutely.
Do you have a question about ION4RAW? Any curiosity or?
Yes, sure. Actually, I have a question for Maria. Let's say about really the efficiency and the flexibility of the DES, let's say, or the ionic liquid design, basically, to be able to treat a very wide range of material as the ones they are used in the ION4RAW.
Yeah, we are working quite actively in that, on the flexibility of the desk, because as you could see, we are also dealing with a lot of different metals here. So at the moment, we don't have any interesting results to show, because we are working on that very actively right now. The plan that we have is to use a desk combination that could be flexible enough, but of course we are also studying combinations that are more focused on targeting specific metals. At the end, we will do something related to what you mentioned, Nader. We will make some kind of assessment to see which is the best solution, because at the end we think that the ION4RAW process itself will be very easily to, it will be easy to use one DES or another one for a specific metal. The process itself is quite flexible, and we are also focusing on the innovation of using all the system as only one step. So it's not a problem right now to say, okay, this test is working only for this metal or those metals, but not for all of the ones that we are targeting. But in any case, it's going to be easy to adapt the system to find the proper operational conditions for the system. So it's something that we are also working on, also because we have to achieve high recovery percentage. So yeah, it's a target that we have to achieve within the tasks in the project. So
Absolutely. And I have another question to Maria. Basically, this is about, let's say, the type of, let's say, gas or ionic liquid. I mean, without entering too much into details, but is it something that you are synthesizing yourself or considering synthesizing yourself, or you are just like buying on, commercial materials that you buy and then you compose?
we are buying the ingredients for the DES, and we are synthesizing them ourselves. Also, we have to consider here in the ION4RAW process that we have the part of the DES extraction, and we have also the electro recovery. So it is also important to select DES which are possible to integrate with the electrodeposition part. Also, the characterization of this has to be very in line with what we want to recover after that, no, after the DES leaching. But this, answering your question, Nader, we are buying like the basic ingredients and we are making the DES ourselves.
Another question, maybe. Just
yeah,
like
go ahead.
if there are other questions, I can. But another question for the temperature. Let's say, do you have any idea to what are the temperature range that the desk can withstand, basically, without?
We are working between like 35, 50 degrees. This is the working temperature that we want to have for the extraction, because that sense we are going to have like a low energetic intensive, it's not going to be an energetic intensive process, and it is also compatible with the electrodeposition after all. So this is the range.
Yeah, I have another question for like both projects. We like to ask this question, but what kind of challenges has your project faced? With either like from a technology standpoint or another aspect?
Yeah, in the case of the ION4RAW, there are a lot of challenges because there's technology combined with electrodeposition. There are some research in the literature, but there is not enough to make like a commercial process at the moment. So, and we are also targeting very different metals from very different sources. So this technical part is very, very challenging. I think that it is the most challenging part, at least for the ION4RAW project. And I imagine, Nader, that for the technological part in the Tarantula will be more or less the same.
Yeah, absolutely. I mean, those projects are normally low TRL level of project, technology readiness level. So they are focusing on really, let's say, discoveries and developing technologies that could have a kind of breakthrough, let's say, by the end of the project. So they are by nature very high risk, of course, and then this entails a lot of technical challenges that need to be solved in many different aspects. But actually, it's also promising, let's say, for the future, because in our cases, let's say, I mean, there is a clear need of those material in Europe, as I have shown in the presentation. The EU depending 100% of the import of some very strategic elements, and the market is there, and there are some resources also in Europe. very good resources in Europe. So what's lacking now is really the technology that could be able to valorize and recover them from basically very low concentrates, because for now there is no technology that can really recover them into a economically and environmentally viable way.
And one question, Nader, regarding the identification of the European resources of refractory metals and so on, do you plan to have something public, some kind of report or information on the RMIS platform of the EU? Do you plan to have something like that?
Yes, of course. I mean, some of the results of the Tarantula will be, of course, what can be shared will be shared on the RMIS. But of course, I mean, this is, let's say, those information, not everything, unless it's really protected. But yes, for sure.
I guess another big challenge that's going to really face the world is like COVID-19, and we were just like curious, like how has COVID-19 affected the progress of your project?
Yeah, it affected a little bit at the beginning of, because when the COVID started, we were also starting off all the laboratory experiments, and it was the initial part of the technical aspects of the ION4RAW. So we had a lot of delays. What we did, we make like an assessment, we analyzed the situation. Also, there were some interaction between partners that were affected. And we just make like a plan, and we put everything on the paper. We said we need more time. We need to modify these deadlines, and we discussed it with the commission. At the end, we make some amendment of what we had in mind at the beginning. Because at the beginning the ION4RAW project the duration were like 48 months, and now the duration was extended to 54 months due to the COVID. But apart from that, everything is running quite okay. It was like these delays that had to be put into the documents, some paperwork, but the commission understood everything, and they said, okay, we can modify this, and then you can go on.
Nader, is there any particular?
I think this is a bit the same situation for everyone. I think, I mean, well, in our case, the project started a bit before, let's say, the Corona, but I think since the first year of the project, I think the Corona crisis started, and for sure it affects, let's say, or delayed some of the work because many of the research organization, at least in the first wave, they did not have access to the labs or the experiment as should be, in normal conditions. So this could have some delay on the project, but we still have, let's say, about 1.5 years till the official end of the project, like into May 2023. Probably, if there are no sufficient timing, maybe also some project extension that would be needed to cover for the delay. Something to remain to be seen.
Yeah, it's good to see that, like, it hasn't affected too much of your progress. Really, it's good stuff going on. Yeah, I guess to take away from like the bad things that are happening, we have a question. We were just wondering, what's the best part of like working in a consortium? Because you spoke working quite large consortiums. Is there anything that you think is the best part?
It's very, very interesting, because at the end you are working with very different people with very different backgrounds, living and working in different places all around Europe and the world. And at the end, the challenges are very interesting. All the discussions are quite interesting. So it is very good to see how everyone is feeding from the knowledge and the things that are the results that we're getting from the projects. for me, it's exciting to work in a project with such a big consortium. So yeah.
Yeah, from my side, what I can say, it's of course, I mean, support Maria with all those, let's say, remarks. But I would add also that it's really, really very interesting for basically for all the partners, because you can also see sometimes that. Yeah, I mean, at least at the beginning, let's say some partners are maybe have different interest or different view on the problems, specifically between, for instance, academia or industries. And then later on, when they start discussing, the things start to merge and basically, yeah, I mean, many times, like people, they miss if they are not discussing in those kind of collaborative project, sometimes they miss the real challenge that need to be solved, or they found out that others have been working on this and they have been advanced or did not work and so on. So it's very important in order really to advance very fast, to share this knowledge between a larger number of group, that they have the same interest in the same material or the same technology.
And the problem, I think, is also because now we are not having physical meetings due to the COVID and the restrictions. And with the online meetings, we can discuss a lot. We can put a lot of things into the table, but it's more complicated. It's easier when you are all together in a room and you have the focus on the targets and the objectives of the project, and everyone is following like a line to reach these goals. So now it's a little bit more complicated, but let's see. Even in the coming months, the physical meetings can be held again. So
Yeah, you're kind of just waiting around for emails, aren't you? Now it's kind of no face to face. But yeah, I just have a question to take it back to like the raw materials part. For ION4RAW, for you, Maria. I was just thinking, could you tell us a bit more about like what your project chose the critical raw materials that you're recovering? Is it due to just the increase in demand for these materials, or is there any...
yeah, the idea of these materials is that they are, as you could see, many of them are critical raw materials. That means that there is not enough amount of these materials in Europe, and they have a high price. So at the end, they are quite important for the European Union, and we are importing most of them. So there is a high interest on finding technologies in order to start developing and recovering these materials here, and also these metals, you can see they have very different roles, and they can have an industrial application quite clear. I don't know, batteries, jewelry, autocatalyst, I don't know, alloys, chemicals. So yeah, I think that it is also one of the reasons why the Commission selected the ION4RAW to be funded and to start developing these kind of technologies.
Ah, yeah, it's exciting to see. Yeah, I have a question for Nader, just about one of your raw materials. I've read prior to the webinar that like tantalum is like it's quite a rare metal. Have you had any issue sourcing the metal, or it's just not a problem?
Well, I mean, well, we have one partner with us, Strategic Minerals. So basically, they are operating in Spain, in the Penuta mine, and then basically they will be the supplier of the material for the project.
Oh, yeah, perfect.
So I just wanted to comment because there was a question on the raw material information system. First, we have already, let's say, some basic information about the tarantula in the raw material information system that can be checked. Those were quite early in the project, but hopefully, let's say, it could be like in the future that some of the results that can be shared also could be, let's say, updated this information that we have already on the LMIS.
Oh yeah, we look forward to seeing it. Yeah, definitely. Just like to take a question back to just like circular economy, just because so like recovering raw materials are seen to be a must due to the demand in Europe across Europe and across the world. Do you think the circular economy approach is the right approach to help this like ever-growing demand, or what's your stance on?
Yeah, in my case, I think that it is something that is going to help, of course, to the circular economy. And the idea, because in the case of the ION4RAW, we are working with the primary sources, but as I said also during the presentation, we can see how to adapt the process to use it also for secondary resources, for recycling of the different metals. So at the end, all of this is going to contribute to this circular economy concept.
Well, in our case, it's also I think it's really very direct because we are using the wastes, let's say, of the mine, like let's say the tailings. Basically, those are low grade, let's say, feedstock that were not not interesting in the last years because there was no technology to recover them. And it was, let's say, very difficult or economically not feasible to recover them. Now, as the technology is evolving, but the hope is that we could find really the technology which is economically viable and environmentally also viable to recover those low-grade material with interesting costs, let's say, competitive costs to put them again on the market. Also, we are considering the in-process waste, for instance, from let's say the carbide production cycle, which can be in different forms. It can be defected materials, it can be powders, it can be different, let's say, material that is really like lost in the production, which is quite considerable also to be valorized and re-injected into the economy.
Yeah, it's really great to see the circular approach being, brought in because it's something that we have felt they really want to promote. Yeah, look, I think the webinar has been great, and I think we could wrap it up. So I'd just like to thank Maria and Nader for attending and showing us the fantastic work the projects are doing. If you'd like to watch your webinar again, it will be available on YouTube soon. And I'd just like to also thank everyone for watching the webinar and just to inform you about our next webinar. It will take place on the 5th of January, and the episode will be about agriculture and bio-based solutions. So to join us for the episode, we have invited Horizon 20 projects, Rustica and Be First, to help us in that discussion. So again, thanks again, and I hope you all have a good Christmas.
Thank you very much,
Thank you
Robert
very
and
much.
Nader.
Thank you, Maria.
Bye.
Bye-bye.
Bye-bye.